Hi guys, in this video we will be practicing using U-substitution to complete integrals. So the first example I want to show you is the integral of 1 over the square root of 9 minus x squared dx. Now we can see that this looks similar to the form of the integral of 1 over the square root of 1 minus x squared, which equals sine inverse x plus c. So I need to find some way to rewrite 1 over the square root of 9 minus x squared in this form, 1 over the square root of 1 minus x squared. The first thing I'm going to do is rewrite this as the integral of 1 over the square root of 9 times 1 minus x squared over 9 dx. Okay? And next, I'm going to take out 9 because it's the same thing as 3 squared. So I'm going to take out a 3. And this will become the integral of 1 over 3 times the square root of 1 minus. And then I'm going to change this to x squared over 3 squared dx. Now I can take out a 1/3. So I'm going to get 1/3 times the integral of 1 over the square root of 1 minus. And now because I have x squared over 3 squared and that power is the same, I can rewrite this as x over 3 squared dx. Now I'm going to let u equal x over 3 and du dx will equal 1/3. And therefore, dx will equal 3 du. So now I can say I have 1/3 times the integral of 1 over the square root of 1 minus u squared, 3 du. Well, I can bring out that 3 and multiply it by 1/3, and I get the integral of 1 over the square root of 1 minus u squared du, which equals sine inverse of u plus c. Now, remember up above here, I said u was equal to x over 3. And all I have to do is sub that in, and I get my final answer of sine inverse of x over 3 plus c. And that right there is the answer to the first integral. The next integral I want to do is a definite integral. So we haven't worked with definite integrals much. So this integral is going to be the integral from 0 to 1 of x cubed plus x times x to the 4th plus 2x squared plus 9 raised to the 1/2 dx. Now, for this one, I can see if I let u equal this function right here, I'm going to get a 4x cubed term. And it's going to look like that's going to align up with my x cubed term, and it may be able to eliminate this. So let's try letting u equal x to the 4th plus 2x squared plus 9. Then du dx will equal 4x cubed plus 4x. And when I solve for dx, I get dx equals du over, and I'm going to factor out a 4. 4 times x cubed plus x. Now I can sub it. Now, whenever we're in the u world, because now we've transitioned from the x world to the u world, I have to reevaluate my boundaries. So what I do is I plug in 0, which was my first bound, into u. And when I do that, I get 9. And then I'm going to plug in 1 to u, and I get 12. So now I have the integral from 9 to 12 of x cubed plus x times u to the 1/2, because I put u as that, du over 4 times x cubed plus x. Now notice this. This is nice because my x cubed plus x terms cancel, and I can bring a 1/4 out to get 1/4 times the integral from 9 to 12 of u raised to the 1/2 du. Now I can use the power rule, and I get 1/4 times 2/3 u to the 3/2, and I'm evaluating this from 9 to 12. So now this is going to be 1/4 times 2/3 12 to the 3/2 minus 2/3 9 to the 3/2. Now I have to evaluate this. This is going to be 1/4 times brackets, and this is going to be the same thing as 2/3 times the square root of 12 cubed minus 2/3 times the square root of 9 cubed. So this is going to be 1/4 times. And notice that I can take out a 12 squared because I have a 12 squared in here. So that's going to become 2/3 times 12 times root 12. 2/3 times 12 is going to be 8. So I get 8 root 12 minus, okay, 9 cubed. I can take out a 9 and I get 2/3 times 9 root 9. But the square root of 9 is 3. So really the square root of 9 cubed is 27. And 27 times 2/3 is going to be 18. Now notice I can still simplify this radical. I can say that this is going to be 1/4 times 8 root 4 times 3 minus 18. 4 is 2 squared. So I can bring out a 2, and I get 16 root 3 minus 18. Then I distribute my 1/4, and I get 4 root 3 minus 18/4, and that simplifies to 4 root 3 minus 9/2. And that is the definite integral from 0 to 1 of x cubed plus x times x to the 4th plus 2x squared plus 9 raised to the 1/2 power. Now the next problem that I'd like to do is the integral of 3x squared plus 4x plus 1 over 3x cubed plus 6x squared plus 3x plus 5 dx. Okay, so for this problem, I can see there's not going to be a nice way to simplify this, so I'm going to have to use U-Substitution. Now, let's try letting u equal my denominator. So u is going to equal 3x cubed plus 6x squared plus 3x plus 5. When I differentiate u with respect to x, I get du dx equals, now use the power rule for derivatives. I get 9x squared plus 12x plus 3. And then when I solve, I get dx equals du over, and I'm going to factor out a 3. 3 times 3x squared plus 4x plus 1. So now I'm going to rewrite this, the integral of 3x squared plus 4x plus 1 over u du over 3 times 3x squared plus 4x plus 1. Notice how nice this is. These terms cancel, and I get 1/3 times the integral of 1 over u du. Now, we know that 1 over u du is a common integral, and it's the ln of the absolute value of u. So this can be 1/3 ln of the absolute value of u plus c. And now all I have to do is sub back in u, which I let to be 3x cubed plus 6x squared plus 3x plus 5. And I get 1/3 ln of the absolute value of 3x cubed plus 6x squared plus 3x plus 5 plus c. And that is my answer for the third integral. Now our fourth problem is the integral of 1 over x squared plus 4 dx. Now, notice that this form looks familiar to my integral of 1 over x squared plus 1, which equals tan inverse x. Looks very familiar. So, and I should write a plus c here. So we have to somehow manipulate this 1 over x squared plus 4 to try and resemble 1 over x squared plus 1. So the first thing I'm going to do is I'm going to factor out a 4, and I will get the integral from the integral of 1 over 4 times x squared over 4 plus 1 dx. Now I can take out a 1/4, and I get 1/4 times the integral of 1 over, and I'm going to rewrite this as x squared over 2 squared plus 1 dx. Now, notice that for this integral, I have the same power, so I can rewrite this as x over 2 squared plus 1 dx. And now I'm going to let u equal x over 2. I'm going to take du dx, and I get 1/2. Now I'm going to solve for dx, and I get dx equals 2 du. Now I'm going to rewrite my integral, so it's going to be 1/4 times the integral of 1 over u squared plus 1 times 2 du. I can bring out that 2, and this will become 1/2 times the integral of 1 over u squared plus 1 du, which equals 1/2 tan inverse u plus c. And now all I have to do is sub in u as x over 2, and I get 1/2 tan inverse x over 2 plus c. And that is my answer for integral number 4. So far we've done these 4 integrals. And the 5th integral we're going to do is going to be this. It is going to be the integral. So here's another definite integral. The integral from 0 to 1 of x plus 2 times 3x squared plus 12x plus 1 raised to the 1/2 dx. Now I'm going to try letting u equal 3x squared plus 12x plus 1. So I'm going to say u equals 3x squared plus 12x plus 1. And I get du dx equals 6x plus 12. And when I solve for dx, I get dx equals du over 6 times x plus 2. So now I'm going to rewrite my integral, and I have the integral from. Now be careful here. I have to rewrite my bounds because now I am in terms of u, not x. So when I plug in 0 for u, or when I plug in 0 into the u equals equation, I get 1. And when I plug in 1 in, I get 16. So now I have the integral from 1 to 16 of x plus 2 u to the 1/2 du over 6 times x plus 2. Well, look at how nice this is. My 6 times x plus 2 cancels, and I get 1/6 times the integral from 1 to 16 of u to the 1/2 du. Now all I have to use is the power rule, and I get 1/6 2/3 u to the 3/2 from 1 to 16. This is going to be 1/6 times 2/3 square root of 16 cubed minus 2/3 square root of 1 cubed. Now this is going to become 1/6 times. Now for this 16 cubed, I can take out a 16 because I have 16 squared. So it's going to be 2/3 times 16 times the square root of 16. And that's going to equal 32 over 3 square root of 16. And I am going to subtract this. Now, the square root of 1 cubed is 1, so I just have 2/3 here. And now I have 1/6 times. Now, notice we have the square root of 16. Well, that's just going to be 4. So I can say now I have 128 over 3 because 4 times 32 is 128, minus 2/3, and that is multiplied by 1/6. Now I have 1/6 times 126 over 3, and that is going to be equal to 126 over 18, which is the same thing as 7. And therefore, 7 is my answer. Now, our last and final integral is going to be the integral of 4x to the 4th plus 3 over 4x to the 5th plus 15x plus 2 dx. Now, I'm going to let u equal 4x to the 5th plus 15x plus 2, and I get du dx equals 20x to the 4th plus 15. And then I'm going to solve for dx, and I get dx equals du over, and I'm going to factor out a 5 at this point, 5 times 4x to the 4th plus 3. And I'm going to rewrite my integral as 4x to the 4th plus 3 over u du over 5 times 4x to the 4th plus 3. Now notice how nice this is. 4x to the 4th plus 3, they cancel. And I can bring out a 1/5, and I get 1/5 times the integral of 1 over u du. And that's simply equal to 1/5. And this is the common ln absolute value of u integral plus c. And now all I need to do is sub back in my u. So this is going to be ln of the absolute value of 4x to the 5th plus 15x plus 2 plus c. And there's the value or answer for my 6th integral. So notice that these integrals were a little tougher, and that's to be expected. And I'm going to try and zoom out to see all the work we did. So this is all the work we did. You can see our first integral was the integral of 1 over the square root of 9 minus x squared. Our second integral was x cubed plus x times x to the 4th plus 2x squared plus 9 raised to the 1/2 from 0 to 1. Our third integral was 3x squared plus 4x plus 1 over 3x cubed plus 6x squared plus 3x plus 5 dx. Our fourth integral was 1 over x squared plus 4 dx. Our fifth integral was the integral from 0 to 1 of x plus 2 times 3x squared plus 12x plus 1 to the 1/2 dx. And finally, our sixth integral was 4x to the 4th plus 3 over 4x to the 5th plus 15x plus 2 dx. Thank you for watching, and don't forget to like and subscribe, and make sure to check out my other videos.